Good morning / good afternoon. I wonder if I'll manage to solve the last, how many? 8 problems? We'll see. What ID? That's Genie. Hello, Giuatomo, Bipo, Damsek, Rapid Reels, Sudanshu. Hi, everybody in the chat. What did I usually open? We need stopwatch. And text description, we will start from this task. Is it good to read the editorial if not able to solve 1400 level problem, or is it a skill issue? If you keep solving problems, or if for basically every problem that you solve you are not able to solve it and you need to go to the editorial, then it means you're solving too hard problems. If it's like 50% of the time that you manage to solve it and 50% of the time you cannot do it, and then you look at the editorial for some hint, that's perfectly fine in my opinion. Just don't read the full editorial, there is no need for that. Assuming that the difficulty is okay of a problem, so you have some chance to solve it, then from editorial you should get a hint, not the full thing. You can find some of my AdCoder streams and see how I approach it. I usually try to go to the first sentence that I didn't realize before in the editorial, then I stop reading it. Recon says that day 20 part 2 does not meet requirements of the task. We'll see. We'll see. Okay, let's go. I don't think this in this stream it will hurt somebody a lot if they don't start or they don't join right at the beginning. If somebody joins later, it's fine. Sometimes editorial has many Mafi proofs. I mean, yeah, it's also a skill, though in competitions you don't need to prove. Editorial should contain a proof, because otherwise why somebody can ask why does the solution work. Doesn't mean that you need to go for a proof, though it's also a skill. So if you don't know why something is correct, it's a valuable experience to read the proof in the editorial. Can't watch the stream today, that's fine. Hey, there is a recording later, though. I understand that it's not exactly the same experience. It's such a strange thing that even though you might one might interact, one might not interact at all with a stream, not really ask questions, stuff like that, but still for some reason it's just more enjoyable to watch streams live rather than to watch a recording. How to choose problems to solve? I mean, solve recent problems of proper difficulty. That's fine. If you are a beginner, you might also go through some problems, at least like this one, CSES. So this, pasted a link. It will teach you a lot of important stuff. And when you cannot solve something, look it up online. Okay, let's go. This is problem 18, part 1. I want terminal at the bottom. 18 CPP. Do I have some kind of template? Yeah. Stopwatch. Let's go. Create a list of which bytes will fall in the order they land in your memory space. Two-dimensional grid with coordinates from 0 to 70. X and Y, that's column and row. You are in the top left corner. You need to reach the bottom right corner. Simulate the first kilobyte falling into memory space. Huh? So are they saying that we should take the first 1024 input elements? That's very strange format. I'm not sure if I understand correctly. There is this number of elements here, and it seems that they are saying to consider the first 1024 elements. It's not the same if you take it slowly. Is it answer to somebody's comment, or it's to me about solving a problem? And we are asking for the shortest path, so just BFS, right? Well, my understanding is that we should read the first 1024 elements, so that's what I will do. Repeat 1024 times, X and Y, read, we'll skip white spaces, then X and Y, I don't know, blocked or something like that, blocked of X, Y, or more like YX, doesn't matter, is equal to true. Assert not blocked of 0, 0, because that's where I start. We create a queue. I push back the starting element. Distance of this starting element is 0. For everything else, its distance is infinity. about absolving them in a relaxed and chill manner. But do you think that advent of code should be about trying to solve it very fast? All right. We have this blocked. I guess it's most convenient to create it here. And let's make a variable for the grid size. Let's say size will be s. Okay, blocked can be basically my visited. Well, I don't really need it because I can check if some distance is infinity. Waiting till midnight, tryharding all the way. Well, I don't think it's very interesting or healthy for a month to always be ready at some particular time. I mean, competitions are nice, and this is when once every few weeks you can actually try to solve problems as fast as possible. But to do it daily for a month, well, especially in Poland. In Poland, it's early morning. Okay, you are at this row, at this column. Now you consider 4 possible directions. Let's go full screen. -1, 0, 1, 0. For every direction, then you are here. How many problems already required us to iterate 4 directions in the grid? This is like the 5th problem? Okay, if this cell is not visited yet, then mark it as visited. Its distance is my distance plus 1. Push to the queue. And finally, I just want to print the distance of the final cell. It's not healthy, that's the point. I was up at 6 a.m. for 25 days. Okay, Jaron, I mean, it's impressive, but I wouldn't want it. 408. Is that reasonable? I think it is. Right answer. Okay, strange statement. And let's reset the timer, change the text next to my face. Determine the first byte that will cut off the path to the exit. What are the coordinates of the first byte that will prevent the exit from being reachable from your starting position? Provide the answer as 2 integers separated by a comma with no other characters. Okay, I mean, one possibility here with such small input is to just try all prefixes. Another is to binary search. If you know that eventually some prefix will make it impossible, then you can binary search. And finally, I'm guessing you can go backwards for the input and do union find to verify when the path appears. So let's do that best solution. This will be called 18part2.cpp. So I will do it in good time complexity. First, let me explain. More grids coming? I'm not surprised. It was nice until I needed priority queues. Are priority queues hard to use? Okay, if you have a grid or actually any kind of graph, and some cells, 1, 2, maybe I will, well, please work. Okay, maybe I will make a copy. So if some cells become blocked, generally in graph, this kind of dynamic connectivity is hard to handle when things disappear, when they stop being available to us. So if somebody blocks this cell, then this one, then this one, then this one, then this one, and let's say this one, and now we cannot go from the beginning to the end. There might be, of course, some more cells like 7 and 8. What instead we can do is consider this process backwards, because while in a graph it's hard to remove a cell, remove a node, what we can do is well, start by saying that all of them are here. Actually, I don't need this second graph. Never mind it. I can now consider things backwards. So I can start by saying that those 8 cells are blocked. And now running DFS or BFS, I don't see a path from the beginning to the end. There are also other ways to check it. But what I can do is now backwards, I can try unlocking elements. I can say this 8, now it is available. In particular, in union find, it connects those two neighbors. Then this 7, it becomes available. So I maintain this graph. Then after 7 comes 6. And what happens when 6 gets unlocked, when going backwards, is that those two connected components become one, and now the start and the end are in the same connected component. So the algorithm is go back first, assume that everything is blocked as the input elements, then going backwards, unlock elements using union find, or also called disjoint set union. Always when something appears, then it connects neighbors with it, and neighbors that are also unlocked. And eventually we will realize that the starting element and the target element, those two corners, are in the same connected component. When that happens, we say that this is it. This is the cell. So that's what I'm going to use. And the time complexity is n squared, or the number of elements in the input, multiplied by log star of, well, n squared. This is time complexity of union find, which can be a little bit better than, or is it log-log? It's a little bit better than binary searching and just doing logarithm of it. Yeah, tired beaver. You can just rerun your algorithm and then it will be better. What about trying to get linear size, like O of s squared plus input size? Jeroen, is that possible? In general graphs, I don't think it's possible to detect when something becomes disconnected, even offline. Maybe a grid has some special property. Oh, actually, I remember how to solve this online. I mean, this thing, you don't need to go backwards. Here's even more funny solution. What I described, you can apply to a dual problem. What it means is that here's a simple lemma. If there is start and target here, I can instead say that all the cells here, maybe let's say those cells, this is node A. All the cells, let's say here, are node B. And there is this lemma coming from the fact that this is a planar graph, that S and T are connected if and only if A and B are not connected. If there is a path of blocked cells between A and B, of blocked cells, then it's a passage that you cannot traverse. So maybe this cell is blocked, this one, this one, this one, this one, this one, and this one. Then you cannot travel from S to T. Also, in this, when we interpret this like that, it's enough that two cells touch by a corner. So yeah, you can, as you read the input cells, you can maintain this joint set union of blocked cells. Two cells should become connected if they touch at least by a corner, and you wonder when something from here is connected to something from there. Once that happens, you can say that this is it. You don't need to go backwards. You can also do it for arbitrary graph in linear time. Huh, how? I think it's also possible to do something like Dijkstra, where if every cell or node is numbered by time when it is blocked, you can try to find a path that minimizes values used or maximizes them. Maybe that Dijkstra will only use small values, so it can be done linearly. I think that's it. Yeah, okay, so that's Dijkstra with it's linear Dijkstra. Okay, makes sense. So then let me explain what that is. Do we have this drawing? Yeah, we do. Let's get back to this and let's write again. So now linear solution. There are some other values here. I don't remember what exactly. You want to find a path from the from the beginning to the end that doesn't use small values. It should only use big values. If it doesn't use any value, let's say that by default it's infinity. What you can do is you can run Dijkstra from the start that for every cell will try to compute, it starts as infinity. So let's say that's value 9 here. This 9 means that I can get to this cell by visiting only values 9 and bigger. If I want to get here, I need to use a value 7. And if I want to get here, I will not write 1 here because going with Dijkstra from here is better. Well, actually going to here requires visiting this cell itself. But then going with 7, it's better to go around the 1. And like that you can propagate 6, 2, 6, 3, 6, I think. Always when you see that you could arrive at a cell by using only values 6 and greater, you can apply that to neighbors. And you here, of course, prioritize big values, because what it means is that you did not use small values. You managed... what I'm saying is correct? Yeah. Because you want to avoid cells that are very early on blocked. You only want to use cells that are late blocked. There is even a way to do it for weighted graphs with big weights. That's surprising. I mean, there are some algorithms like finding the median, so randomized algorithms that happen to be linear. Is that something like that? Oh, median. Yeah. I see. Yeah, that seemed to be the main possibility. How we could, among a lot of big values, find one of them that satisfies something. The main way to do it, I think, would be with randomized algorithm. Minimum bottleneck spanning tree. Well, we don't exactly want a spanning tree here. We want something simpler, right? There's also a reverse DSU implementation at Codeforces using DP plus segment tree plus DSU. Is it useful? Why segment tree? Is it segment tree to find the minimum? Then like segment tree instead of priority queue? Median can be done in non-randomized way. Well, yes, but who does it that way? The magical fives, right? Okay, so I'm going to do this linear Dijkstra thing. I find it interesting. That being said, by making such decisions, I'm decreasing my probability of solving all the problems today. So we need to redo a lot of things. I'm going to do it in O of n squared with linear Dijkstra to maximize IDs of blocked cells used. Something like that. Now we are going to do this. Let's just do this many times. 3, 4, 5, 0. What do I need to print then? I need to print one of them. I think I need to save them as well. There is input, and here I'm going to say input and place back, and also value at cell xy is equal to I, or let's say I plus 1. In other cells it is 0 by default, or should I use some kind of infinity? Yeah, let's use infinity. By default, for all the values, what we put is some kind of n plus 1, I think. So the blocked cells get values from 1 to 3, 4, 5, 0, and other cells get n plus 1. So this plus 1 as the infinity value. Okay. Now, normally you would implement Dijkstra with priority queue, but here we want to start from value n plus 1 and go down to 0, to 1. And here I want to iterate cells, let's say me, that have exactly this value. I will have an array inverse. That given value, it will give me a list of cells with this value. Like that. Initially, I need to say inverse of value of 0, 0, and place back 0, 0 itself. This is how I start. Now, when I see a cell, first of all, if its distance inside of Dijkstra, distance of 0, 0 is this thing. So value is the initial value from the input, or should I just overwrite it? Yeah, I can overwrite it. I don't need two separate arrays. So let's use value. We have this. First of all, if value of me, if value of this is not equal to v, then it's a zombie element. It's an element in priority queue. Well, I don't really have priority queue, but it's element with some old value that I already improved to a better value. Otherwise, I'm going to iterate neighbors. Always we have this. And the possible value there, so with how big values I can arrive there, let's call this x, is minimum of my value and the value at that neighbor. If this improves something, If it improves something, then correct it. And to the inverse array add that cell. If I do it this way, then I also need to initialize for all the cells. No, I don't initialize all the cells. I think I need two separate arrays. Value inside of a cell is different from how we can arrive there. Or at least then I would need some kind of visited array. Okay, let's use two separate things. This is bigger infinity. That's becoming dangerous. Okay, so inverse of, well, distance of 0, 0 is equal to this. I will say that. And here, if x is smaller than distance, then this is an improvement. So what is that? Distance of R to C2 is x. And do this. Okay, I hope it is correct. And is that everything? Then finally I need to get the ID, which is distance of the final cell. This thing goes from 1 to something, so I need to use ID minus 1. And I need to print, how did I call it? In. ID first, second. But alk. I messed something up. Line 25, inverse of this. Well, that should be slightly greater. Zero, zero, that's not good. 3, 4, 5, 1. Yep, that's not good. Will the iteration of inf of v go right? Oh, you're right, Jaron. Yes, thank you. That's not correct. You cannot iterate a vector while possibly push back into it. That's a tricky bug. All right, something else is wrong. Apparently, it's so. What does it imply? The value was not minimized. I didn't manage to improve the situation. How do we start? We start with saying this. By default, the distances are big infinities. And I push this back to that. Okay, I start here. I iterate elements that are inside of here. If value, not value, the distance. If distance is not v. Okay, I got something. ID 0 is something I do not like. Why would it be 0? So this suggests that already the first element Yeah, the first element is the one that blocks me. That's not good. How could it happen? Also, what is the array that I'm getting? Well, there is an array, and it has some values that are reasonable. Then it seems that what was computed here is a 1. That's because I here keep using minimum, but I shouldn't do that, right? I maximize the target. So here I should say something like this. I want big values there. So by default, instead of distance, there should be values like 0, I think. And then if x is greater, then I insert. It still will go in decreasing order. I think this makes more sense. Otherwise, my program just detected that it can go through 0 or a 1. Well, that's something. Let's see. Right answer. Hooray. Okay, so summary, what happened. 60 lines of code minus comments, so 50 lines of code, nice linear solution, is that as I read elements from the input, in those cells I write values, the ID of this thing. So this is ID 1, ID 2, and so on. This way I fill a grid. The cells that are not here, I assume that they are blocked at time infinity. Also, let's stop the timer. Then I see a grid, which we saw here, by the way, and I run something very similar to Dijkstra there, where I start from top left corner, and I try to get to the bottom right corner by using only big values. A small value is bad because this represents a cell that is blocked very early. So I try to avoid it. I prefer to get here to, let's say, this cell by using only big values. So this value, this value, this value, this value, this value. So when I get here to this highlighted cell, the best option for how to get there is for those values in this column. And the smallest of those values is 3100 something. It means that I can get here by cells that will not be blocked before the time 3155. And this is the distance that I put here. Always when I have some distance here, I consider moving to the 4 neighbors, and to each of them I possibly propagate the value of when I could get here, and I consider the new cell. So if I see that the new cell is 1007, this is when this cell is blocked. So I can get here only up to time 1007. And this is what you see here, where I say I take minimum of my value and the value here in the neighbor, where this my value is the distance how I could get here. And if this is better than what was in that neighbor before, this is standard Dijkstra logic, I overwrite. And normally we insert to priority queue, but because the values here are only from 0 to n squared, you can avoid logarithmic priority queue. You can do it linearly. Something slightly similar, and something that you want to learn maybe for coding interviews, is 01 BFS. If you search for this, you can also search for 0k BFS, 1k BFS. It's slightly related. So this might be a block that is interesting to us. One KBFS. Here you go. Okay, so that was an overkill to solve the problem. I just wanted to do something fast. Let's try to be faster and let's try to be more stupid with the next problem. Close the alt tabs, reset the time, change the title. Start, and let's go. Why do they highlight strange words like finally? Is there some hidden message? FATTFPO. No. Why is this highlighted? The staff get you arrange their towels. Every towel is marked with a pattern of colored stripes. There are 5 characters. So just a string. List of designs. Collect together all the available towel patterns and the list of desired designs. So this is what we have available, and this is what we want to construct. Some are possible, some are not. How many designs are possible? Okay, so easy DP solution where I try every substring and I just see if it can be matched here. So if R is there, and this is prefix of this design, then I know that I can handle this prefix, and I wonder if I can do R or RB, RBG, and so on. I don't do it greedily because I can be stuck. So instead of greedy, it's dynamic programming that just tries to figure out which prefixes are possible. I guess you can also think about it as BFS, but for me it's DP. And checking if substring is equal to something can be done in different ways, like with hashing or with try. I'm going to do it just with a brute force. How do you do it? What is the most convenient way to read this, I wonder? Maybe getLine, right? Well, I wonder what will happen if I do this. While I read this, let's print. Is this meaningful? No. Okay, so I cannot force it to read a comma. What if I do this? And then I can read the next character and expect a space. We got www at the end, and that's the last one. That's good. That being said, comma was also read. This is not what I expected. I thought that this will be a character when it stops. Well, I guess that's fine. So will I get the same behavior right now? Yeah, exactly the same behavior. Ah. Okay, and now what do? I want to collect the strings. Those are patterns, towels? I think patterns. That's a long word, I don't like it. Paths, let's say. Paths, pushback, string of s. And now if the last character is a comma, then remove it. Paths, not puffs. Okay. Then what do we have next? We have those strings. While this. Okay, I hope properly read the strings. So for each of them, we'll do something independently. Let's take the length of the string. dp. You can start at position 0. At the end, if dp of l is true, so if you could get to this index, then answer plus plus. And what do we do in between? For every position, if we could get here, then we check for every pattern if it fits there. For string p in paths, we check if p fits there. If I plus, let's take the length of p. If I plus k does not exceed l, then let's go just character by character. If s of starting from position I doesn't differ from p of j. And now if we are okay, it means that this pattern fits and dp of I plus k should be true. So you can cover the next k characters with a pattern. 306. That was 8 minutes. Half of that time reading the input. Wait, I need to reset and change the text. They don't like my towel arrangements. I think I'm not reading www pattern. I did. I think I saw it in the output. Let's stop the timer for a moment. I'm quite sure that I did see it. But if not, then indeed I was lucky. Oh, break. Yeah. I was lucky. But I'm quite sure that I saw this before, maybe before I changed this from a comma. I mean, I understand how this is bad. What I should do is this. And I was like, there was maybe 20% chance or so that I was so lucky because the input size is quite big. No, actually, wait, that's strange. Oh, I see. I'm guessing that in this, among those patterns, there is something shorter than www that's will do the same job. Maybe there is just W. Yeah, that was strange. Here you go, there is W. I was very lucky, I agree. Now it should be correct. Now let's continue. Thank you, Jaron, for good observation that my code is wrong. Add up the number of different ways you could make each design. Okay, so that's easy to do because of the solution I'm using. Because just like you can do Boolean values, you can do integers with information how many ways there are. I'm blindly guessing that integers are enough. I'm running a wrong file. Ints are not enough. This still seems scary. It's a high number, but it's correct. Okay, so this version was easy. Let's move on. Problem 20. Another grid one. What's for dinner? I don't know. Today I have some like box food. How do you call things like HelloFresh? Is it catering? I'm not using this company, but and generally don't use companies sponsored by YouTubers because likely they are overpriced. Meal kit company. So is that how you call it? Meal kit? Do I have meal kit today? Delivery. But delivery is usually reserved for something that you order, just this single item, this single dish. Where here in the morning I get not ingredients, but just ready food, all the dishes for the day. No, I'm not in Huawei full time. I'm like quarter time Huawei employee. Like, not even that. So there are months where when I do nothing for them. Just from time to time they ask me to do something, and it's a B2B cooperation. Prepped meal. Okay. It's contract work indeed. Stopwatch. Algorithmic research? No, I'm not going to do that. 19 was fun. I mean, it was boring for me. It was a very standard algo problem for me. Race condition. Map of race track. Well, grid. Again. There is start and end, walls. Up, down, left, right. You can cheat. Exactly once. You can disable collision for up to 2 seconds. Does it mean I can go through a single piece of wall or two pieces of wall. Each cheat has a starting position. Okay, I thought that this is just a superpower that I can turn on whenever I want. One piece of wall. It's a little bit strange, this definition. Each cheat has a distinct start position and end position. Okay. So you need to consider every cheat separately. I thought that they will ask us for the shortest path from start to end among all possible cheats. Here, the cheat is defined as two positions. So let's see. This is here, this is here. So it is a wall and where you will exit. So something like that. A wall and a position where you exit. Okay, so should we consider every element separately, or do we want to do something like meet in the middle? Because you can run BFS from the beginning and from the end, and then for every position, if you consider a cheat being there, then you combine two things quickly. How big is this? It's small. 140 by 140. Still, it seems nice to solve things in good time complexity. So how would I solve it? I can iterate pairs of neighbors where there is a wall and something that is not a wall. And I wonder what is the distance from the start to this wall and what is the distance from this dot to the end. And the sum of that is a possible answer. Plus, additional, I need to know the distance from the start to the end. I guess I'm going to do it in this linear time complexity. So just one BFS from the start, one from the end. And then every pair of neighbors I will consider in constant time thanks to those pre-computed values. Those problems, they seem to be repetitive a little bit. I'm trying to remember how I did this reading in previous problems. Was it guaranteed that it's a square? No. (141 by 141). That makes sense. I'm looking for the start and end. If this is the start, then remember its position and change to a dot, so it would be treated as a cell that is accessible. Similarly, if this is the end, now I want to run two BFS. Let's have a function then for that. Given a starting cell and given this, I think, by reference, so it would be populated. Or should I maybe return it? Yeah, let's do it like that. Not DFS, BFS. Starting from this cell, I want to compute all the distances. By default, we fill things with infinity, except for the starting cell. We want directions again. The order of them doesn't matter, I think. Here for every direction. If you're not visited, then your distance is my distance plus 1. Add it to the queue. And at the end, return this. Finally, I need this function inside. All right, BFS is ready. Then BFS of start, BFS of end. Oh, I need to look at the cells. So here, I don't want to propagate from walls. I'm going to do it, but I want to still compute distances to walls. So if this is a wall, A of RC is equal to, is it hash? Yes, it's a hash. And continue. But still distances to walls will be computed, which is important. Now let's see, the normal distance from the start to the target is distance from the start to the target. And now for every cell that is a wall, let's say, if this is a wall, I'm going to iterate the neighbors. Maybe I should have used a function for neighbors. Well, if your neighbor is inside and it's not a wall, if inside and not a wall, then this is a possible cheat. And we look at A of RC plus B of R2C2. Do we do plus 1? If we have 1 and 1, well, still there is one more to move between them. And what do they ask? At least that many. If here is smaller or equal than normal minus 100, then answer plus plus. I wonder if we will get positive answer. $1,300, that's a lot. But if this is a big maze, it makes sense. Do we have some drawing here? There is this shape in the middle. Let me, I wonder if there is something here. Right answer. So let's pause the time. What if I double every character to make this appear wider? No, I don't see a particular shape. It's just a maze with something randomish in the middle. I wonder how it's created then. Was it a random process? You can use AutoDRDC dirs for easier typing. Yeah, I kind of know. Many people told me that. So here, for example, you're saying that I should have used for auto dr dc in dirs. Does it still work? Yes, it still works. I will try to remember. So thank you for a suggestion, obviously. Why not use Q for BFS? Q is slow in practice. It has its advantages, but C++ vector is fast and convenient. So it can be used for almost everything. Well, I believe that Q is slower, question mark. Actually, I'm not 100% sure, but I think so. If you want to erase elements, just if you don't actually need to erase elements from memory, then it's better not to do it one by one because it takes time. So it's faster to iterate vector than to iterate Q and as you go erase elements. So this is why I use vector, but it has a big disadvantage that if you iterate a vector that is modified as you go, you cannot do it with an auto for loop. You need to go through indices. Q uses list by default, but you can force it to use vector. Yeah, but if you use vector, still doesn't it use like 2 vectors under the hood? Or does it just then not erase and only has a pointer or index to the beginning? If you force it to use a single vector, then I'm guessing it will have similar drawbacks. No, that under the hood it might store indices. Maybe if you force Q to use a vector under the hood, then it's actually very convenient to solve a problem like this one. Single vector, okay. Jerome, why do you know so much? You can't use a vector for the template argument, it uses deque normally. How do you guys know so much? Okay, now hard version. Reset the timer. Change the text. Single treat that instead lasted most 20 picoseconds. So if for 2 it was entering a wall and then making one step to be outside of a wall, here it's entering a wall and 19 more seconds to be outside of a wall. So we care only about the starting and ending cell of a cheat. Okay. That's, well, if we want a cheat to last this much, then it means I need to start from a wall. Oh, but I don't need to start from a wall, right? Yeah, it's ambiguous, I think. Actually, I didn't read every paragraph, so maybe it is not ambiguous. All right. Well, I'm going to assume. Why is it so small? Okay. I'm going to assume that you can start anywhere, because I didn't see a requirement that you need to start from a wall. So the difference is that now you don't need to start from a wall. You then don't iterate all the directions. Instead, you iterate the other cell that is, if you start here, you want it to be, earlier it was 1 unit away, now it will be at most 19 units away. Now the Manhattan distance, so just the distance of how many steps needed between them cannot exceed 19. And if this is the case, and the final cell where you are is not a hash, then check that. This is the answer I got. Manhattan distance of 20 away. I don't agree, but because earlier it was a cheat of length 2, and we wanted to start somewhere and be 1 unit away. So the path consists of 20 cells, so the distance between endpoints is at most 19, I think. Not the right answer. The answer is too high. Maybe we need to start from a wall. Why Manhattan distance help here? Once you go here. Once you go out the wall, your cheat fails? Is that what the statement says? I thought that cheat means that for the next that many seconds you have invincibility. You are invincible. Maybe I misunderstood. I think there's a bug, no misunderstanding. Okay, then let's think. can't you just binary search the answer? Very rarely you can binary search something that you count. Here we are counting the number of cheats that satisfy something. I don't think there is binary search involved here. Sometimes when you minimize or maximize, then it makes sense to binary search. Can I also iterate elements of a map with this thing? Auto, like that. Frequency map. I want to print what I find for the sample test. My program claims that there are cheats that mess up. Well, if you force it to go somewhere, then sure. Okay, 32 cheats that save 50 seconds. My program disagrees. 3 cheats that save that much. My program claims that it can save more. How does Manhattan distance account for cheating once? You take 6 steps and go out of the wall, then you can cheat again. As I told you guys, I understood that you're invincible for 14 seconds or 20 seconds. So I assume that you can, for 20 seconds, go wherever you want, and then your invincibility stops. The alternative understanding is that once you go out of the wall, you cannot go back. That would require BFS inside of walls. Oh yeah, by binary searching the answer like in the website. So we considered that last time a week ago, when I solved some problems, there is a delay. You cannot just solve every problem in 20 submissions or so. They have some examples here. In those examples, do they only use a wall? Maybe I will open sample. Starting from here, go there, exit here. Oh. No, we are allowed to go outside because this thing goes 2 cells to the right. So yeah, and it is okay. We go here, then step down. I know what is the bug because I made the same bug. Okay. At least then it tells me that it's a bug for sure and not a misunderstanding. I also here consider a cell with itself, but that shouldn't save anything. Should it? I wonder what will happen if I require the starting cell to be a wall. Nothing much changed. This doesn't match their explanation. Why didn't that change anything? Wait. Something strange is happening. What am I doing? This seems to be something very important. Why am I changing it and nothing changes in the output? Okay, now it changed a little bit. Strange. I see the bug too. Okay. Don't tell me yet. Oh, the sample is 15 by 15. Okay, yeah. Then obviously, then it doesn't make sense to experiment using sample that much. Let me use the chat as a yellow duck. Actually, I own a yellow duck because recently I was in some competition, Central European Regional Contest, CERC of ICPC, and JetBrains was giving away yellow ducks. I can bring one. Okay, for every starting cell of a cheat, it doesn't need to be a wall. I consider all the cells that are at most 19 Manhattan units away. Now I can have some typos here, but I don't see them. If something is at most 19 steps away, maximum would be if I could travel by edge as well. Then if that cell is inside, which I don't need to check because of my maxima that I used, though we can simplify the code here and get rid of that maximum minimum. Maybe that will help. And the target cell, the cell where I stop, is this. Well, there is some logical error here, right? It's not necessary now. What is the definition of a cheat? If I clear this path, do I need to actually traverse it? Maybe I clear a path and then from middle of that path it's better to go to the target. But still that does not explain why I print a value, a saved value that is bigger than this. But that's about definition of. I think you should reread the paragraph below the last 2 degrees explained. Cheats don't need to use all 20 picoseconds. Cheats can last any amount of time up to and including 20, but still can only end when the program is on normal track, so the non-wall. Any cheat time not used is lost. It can be saved for another cheat later. But what they showed me here is that I can go outside and then here. All right. And now a strange thing is that I can look at some pair, but actually it might be a bit better not to go to the end of that pair, not to the end of that path. A cheat is the same for every start and end pair. I mean, I see some issue with my logic, but it does not explain why I'm finding better savings than they do. Cheating does not teleport you. But so when I consider a cheat that goes from here to there, the path might be important, meaning that later I try to go from B to the target. But for that, I don't know the shape. That being said, the shape. So depending on what shape exactly I clear, the shortest path from here to the target might be by this cell. That being said, then it's better to do a shorter cheat, just get here to the last cell that I should use on this path, and then get to the target. Right now, my program assumes that once I go through the cheat, then I will not use it again. So it's not that I will go back few cells and use the fact that I still can go through walls. I'm not sure if it's an issue in terms of understanding the story, but still, why would I get saved value greater than 76? Walls stay walls, you don't clear them, you only go through them. Okay, then that's not really an issue. How do I achieve this? Well, what about this? Let's do debugging. If normal minus here is equal to 83, then print something. This is, oh yeah, this is doable. I can print it. You have to consider the time. Oh, okay. I mean, you could have let me suffer a little bit more, but the +1, of course. +1 I used in the easy version because we have 1 unit of time going between those two cells, obviously. Three versus 9, that's not good, but at least the values seem to roughly agree. Why is it 3 times bigger? I more than double count. Do they want me to stop just after a wall? Or do they want me to start from a wall? No, that's not it. Now I'm guessing that I would already correctly print how much time we are saving. I mean, it's not just divide by 2. Note that I have 9 instead of 3, 12 instead of 4, 42 instead of 22. So it's not even exactly divide by 2. Also, I don't think I should divide by 2 because of pair repetition, like AB versus BA, because those are different pairs. Start and end point of the cheat are in an empty square booth. The distance is 20. Okay. So I will consider, for example, starting at an end point, going somewhere, but that will not save me any time. I can also start here, go directly to the end. I don't know why that would be an issue. But here it should be very easy to do the following. If this is 76, print RC R2 C2. I have a lot of cheats going from the start and ending at 7, which is here. 0, 1, 2, 3, 3, 4, 5. Then they are saying that I can start here. Well, yes, all of that works. Also from 4, 1. So that's here. To me, all those solutions are okay. I don't, with my current understanding, I don't agree that it's 3 cheats. But beginning of a cheat can be this, unless by start of a cheat we mean this point just before we go into a wall. But that's a completely different understanding of the statement. So my understanding was understanding is start of a cheat is the first usually wall visited, but not necessarily this. It's the first thing that counts towards that path of length 20. And now I'm guessing that they are saying it's the cell from which you will enter the wall cell. You can start from within a wall. I mean, I think we can do that. This is how they displayed it. For example, here they said 1, 2 for those 2 cells, where the first of them is a wall. But now it seems that this triple is what they treat as this cheat. Okay, well, let's then say that we want to no, the wrong program. Okay. Well, first is I can do this, so I can say if not wall, then continue to try this, but that will not fix everything. What I think we want is we want to change from 19 to 20. And I want to say that I start from, well, let's first try this. But I think we should start from a non-wall. Three, 4, 22. Yeah, okay. So, unlike what this drawing suggests, where is it? This one, where we start a cheat is here, just before entering a wall, usually. That was ambiguous, I think. Soon I will be replaced by AI. My coding skills will be replaced. How do you feel about this? I don't think that's the case. But yeah, it is a possibility, of course. Maybe, what about this? My coding skills are not my main thing, not how I earn money. My skill of teaching is how I earn money, my skill of explaining things. And I don't claim that I'm the best in the world in explaining, but I'm good at it. I'm good at teaching. So for now, this is how I earn money, not by winning competitions. And of course, being good at coding and algorithms helps because this is what I teach. But we are very far away, I think, from the situation where AI is good at explaining and has very close to 100% accuracy, where it's not the case that suddenly it says something very stupid. Of course, I also sometimes say something very stupid. And of course, AI would struggle for more than 30 minutes easily on this problem. And here comes my second attempt. Easy, 28 minutes, right answer. AI is not able to do it, I'm sure. I hope. Let's see. 20. No. This was problem 20. So let's stop. And that's this. Okay, maybe AI is able to solve this problem in 3 minutes. Well, too bad. I hope that I still have some savings now that I cannot get a job. No, AI is still a tool. It increases our productivity, it allows us to be faster at doing different things. Do you think that now people who, I don't know, want to, let's say, create a website will plug something into ChatGPT and it will do everything for them? You still need to, for example, pay for the domain. There is some stuff that still a human should do. Maybe it will be more boring stuff. Okay, reset. But also I'm aware that I shouldn't assume with 100% certainty that in 10 years I will have the same job as I have right now, which is teaching algorithms. AI will be better at giving classes and helping students with homework, stuff like that. I guess that already the market for one-on-one classes might be changing. I don't know it exactly, but earlier students maybe needed more help with homework and now they don't need that. So there is not that much need for classes. Generally, AI messes up the education system because for teachers now it's so hard to fight with students who just use AI instead of solving the homework on their own. Now, some effort for teachers is for figuring out how to avoid that and how to actually check if a student knows something. So in some way, AI and ChatGPT is making teachers' work harder, not easier. OpenAI will train their models on Erichto content super hard from now on. Then on purpose I should make my content incorrect and stupid. And only if you pay me for private classes, that will be the valid, correct content. Okay, everybody, now we will sort in linear time, arbitrary big values with linear number of comparisons. That's easy because you just find the minimum, then you find the median in, of course, linear time, and you repeat that for both halves. N over 2 plus n over 2 is O of n. Easy. What editor? That's Gini. You would see it if not for my face. You see at the top, Gini. Okay, 21, start. Physically typing the door codes. We have 4 rows. Robot is not designed for button pushing. Push the button. Actually, why do we say button but we say push? English is stupid. It has a robotic arm that can be controlled remotely via a keypad. So we can hit up, activate, left, down, right. And now we can have a second robot that controls this thing. So robot arrives pointing here. To make robot type this, you need to do something. Oh, I predicted the statement. Now you need to send a robot to control this thing. That's nice. I appreciate it. Okay, this one I didn't predict. So if I understand correctly, first robot controls this, then second robot controls this, controlling the first robot, then third robot controls this, controlling the second robot, and so on. Two keypads robot are using. Okay, there are 3 robots and yourself. You cannot go out of bounds. Okay, but that's the statement would be enough now. Why are they adding new things? You'll need to make sure that for each of the 5 codes you find the shortest sequence. Oh, so those are just test cases. Okay, fine. I'm trying to understand this. Also, for each of those, you take the number without the character and you multiply. Okay, so this is just hashing description. It's so unnecessarily complicated. Just give me one of those and tell me to print the shortest sequence. Okay, fine. Okay, so Let's make a drawing. I think I understand the statement, but still. There is this, and then there are a few occurrences of those. Okay. I'm a human controlling this thing. And then there are robots. Let's say that. Okay, this is a robot. It is something on a single wheel. It is here at the A button, here at the A button, here at the A button. Okay, good enough. Now I can click something. For example, I can click arrow left, and that controls the next robot, so this one, and it goes left. Then I can hit arrow down. It controls this next robot, which is here, moves down. Then if I hit A, it makes the next robot hit this button, because A means hit. And that thing controls, so this is hit because of that, and it controls the next robot, which moves down according to that arrow. Like that. And what I want to obtain is some kind of buttons pressed here. And this A is just a character. It's not a button that does something extra. So here, those are just 11 things that all do something. Clearly, in this process, the state of the process is where the robots are. So to know what I should do next, I need to know the robot 1 position, robot 2 position, robot 3 position. It's 5 possibilities, 5 possibilities, 11 possibilities. And there is some sequence that I want to obtain. So part of the state is also how many of the 5 characters I already printed. And I can run DP on this. This is just BFS kind of DP. So it's basically BFS on those states. And I want to obtain the first state where the number of characters printed is 5. Then it's a lot of implementation because I need to figure out how those can be moved and how this thing moves. And we need to know that we are in one of those 11 states, and depending on my direction, I do something. Well, how do I do that? How much hard coding will this do? Part 2 was the best Advent of Code problem this year, I think. Interesting. We'll see, we'll see. I mean, this thing we could have a lot of robots, like 100 robots, and then maybe that will be done with some kind of matrices. I don't know. Well, this, I don't want to hard code all of that. So I will say that for values from 0 to 9, the way you can move between them, let's move this down. You can move, well, still the right versus left directions are important. This can be a 2D array. Is that a good idea? Then this also can be a 2D array. Yeah, let's try that. keypad. It contains 7, 8, 9, 4, 5, 6, 1, 2, 3, -1, so non-existing element, 0, and A is, let's say, this. So 10 equals A. Then there is the, no, that's not keypad, that's numpad. Then there is keypad. And this thing has arrows up, hit, and those. I will call this up, hit. Also there is -1 first. Left, down, right. Those values do not matter. This could be some kind of enumerator. Then, given current coordinates of something in one of those two things, I want to be able to move it according to one of 4 directions. So given one of those, I will move. I don't know, F. So given the current coordinates and given a direction, which is one of those. Now let's not be so crazy that hit is between those. Let's say that this is 0, 1, 2, 3. Oops. And hit is 4, in case I need to, for some reason, to iterate directions. So if there is direction, then I will move those things. If if direction is equal 0, not 0, up, return me dot first, so the row -1. Well, I can, I guess, create I can create array of directions. For up, it's -1, 0, because row goes up. For left, it's 0, -1. For down, it's 1, 0, row changes. And for right, 0, 1. Return this plus direction of this first, second. Okay, so then always I will consider moving, and I need to verify if this new thing exists. So if it's not -1 and not outside of the grid. I start by being only on A's. So the initial, well, what is the state? The state is my coordinate, or maybe the value. It's easier to say that it's a value, I think. My state will be how many characters I already passed, and the target is 4 characters. Well, yeah, 4 characters. So state is characters printed, then robot 1, robot 2, robot 3. Robot 3 is on a numpad. The other 2 are on a keypad. We start by saying that we have 0 characters printed, and those are on character A on a keypad, which is the hit. Robot 3 is on this thing, and A is value 10. Everything else should be set to infinity. I want to type vector so many times. This is 5 by 11, not even 11, 5, 11. Those two 5s are from different reasons. We have this, everything else should be set to infinity. Well, I can achieve that easily with second array. And there is some kind of queue, because this is BFS. Okay. Now, iterating the queue elements. Characters printed. Then, actually, can I unpack it? Auto. Will that work? Can I do X, Y, Z? Well, let's say A, B, C, D is equal to Q of Z. Does that compile? No. Well, characters is. If you put array of int comma 4 in the queue, it works. Okay, but I remember that for that array, sometimes I don't know how to do something. I'm more used to vector. Okay, then what? There is robot 1. This might be confused with row, but maybe not here. Yeah, it's fine. Q of Z1. Okay, we have this. Now I consider each of the 5 buttons that I can press. And those are it's very different depending on if it's a direction, which just moves the next thing, or the hit, which behaves differently. That being said, it's kind of recursive. Where is my drawing? So this button will hit something here, which then is applied there. But still, because I hit something here, it's like me hitting something. So it should be the same function. Those robots should be an array of size 3, not really 3 separate variables. Actually, they are an array. I just shouldn't unpack them. So I think I don't want. I will modify Q of Z. Now I consider a move that I make, 1 of 5. And so it's one of those. And I want to say that this, whatever I hit, applies to the second robot, which possibly applies to the next robot, and so on. Apply this move to robot of this index in this state. Let's copy Q of Z. Let's erase the first element. Now V stores 3 robots, that is positions of those robots. Now I want V to be of size 3. I also want index I to be in the range. Average Yusaku Silver problem. Are they so implementation heavy? I wouldn't say so, but that's funny. If this was advertisement of your competition. It's not a bad problem, by the way. The statement is funny. Actual implementation because of those keypads is annoying. But I think the part about DP is, well, it's not very standard. I think for beginners, so for not somebody who is very experienced in competitive programming, this is something nice and interesting to think about. Yusako is hell. I disagree. Which keyboard do you use? Logitech Ultra X Premium. Very fancy name. They don't make it anymore. This thing can also apply a Boolean value whether the move was successful. And it can also check whether some character was printed. So maybe let's return a character. And it can have different states because it can be one of characters returned. So one of those. But also can be information. So it returns character printed or info that there is nothing printed or error. If you moved out of bounds somewhere, one of those should be returned and I will use it then in some way. Okay. Maybe I will use throw and catch. How good was I at Math Olympiads before starting CP? Were you close to making IMO team? Yes. Maybe before I started CP, I wasn't that good at math because I was only like just before high school. But in high school, I wasn't very good at CP yet, and I was very close to making IMO team. Okay, if this is a hit, then I want to apply something to next thing. But if this is 2, then hit means I'm printing whatever I'm hovering at. So I'm going to return the numpad thing. And that's a character. I need to get character. So if I'm hovering over one of those 11 values, I want to get its character. Actually, it's not that I need to iterate this. I just say this if it is in this range, then return 0 plus value. If this is a 10, then return uppercase A. Is it uppercase? Yes, it's uppercase. Also, let's copy it. And else return false. Zero plus get character of v of 2. Okay, this is easy. Otherwise, this is a movement. So this, whatever it is, I want to move. No, I'm still at hit. So if not 2, then it means this is a robot that hit something and it should be applied to the next robot. Apply V of I. This is the move that I'm hovering over. This move I need to apply to the next robot using this, and I return whatever that returns. Okay, otherwise this is movement. If I is equal to 2, then that's movement on a numpad. I don't know, so kind of shift or make move on a numpad. So this is the move, this is the current value, and this is the 2D array that I want you to use. And we return that. Else, return make move of this move of V of I on the keypad. So here, I guess I should just do this. Right, numpad is this, yeah. Well, do I need a function then? Well, yes, let's make a function. Make move, gets a move, gets by reference, that's very important, the current value, kind of x, and it gets a 2D array with this one of those pads. This is the movement, it should go from 0 to 3. Now I need to iterate where I am, or maybe even make variables for height and width. I'm looking for a cell that contains this value, because value x is, for example, 7. Then I need to know where 7 is. For example, it is here, the 7. So search for this thing. If pad of RC is equal to x, then this is me. I should be able to find it. Now I try to apply this move. Do I have directions? Yes, I do. R plus equal directions of move dot first plus equal. Now, if this is out inside the grid, and this cell is not -1, then good, change it, and return, I don't know, some kind of success. Nothing printed. Now, movement. Let's say that's $1 or something. Okay, else we are outside, return error. Let's make what this will be. This. Not movement, error. Of course, this is not good coding style. Those constants are stupid. You should do maybe some kind of template, some kind of enumerator. I'm not sure what is the good way to do it. Don't you need to save the 2D coordinate? I decided a long time ago that I don't want to bother with states that consist of 6 different values, and instead I store a value that is there. I don't know if it's a good idea. Maybe not. Okay, so now I make this thing. Now, if this move is error, then continue. Otherwise, Also, if the number of characters printed is equal to whatever I want, so that's 4, maybe I should get some kind of length of string. For now, let's just print the target. Print, what do I print? Some kind of distance. Distance of what? Oh, I need to here type a lot of things. Oh, that's annoying. So actually, I'm going to collect this. Okay, for now, let's say string s is hard-coded to be this. Okay, this is the distance. Otherwise, if this is equal to movement, then we'll do something. Or maybe, if not movement, then I want this to be the same character that I expect now. So if now printed is not equal to s of characters, it's something is printed, but it's not what I expect, then continue, because this is bad. And finally, otherwise, we have something. Also, this vector changed. Okay. So now I need some new state. I don't know. State 1. This is characters plus, if this was not movement, so if this was not movement, then add 1. Then you have v of 0, v of 1, v of 2. Now this is your state. If not visited yet, this will be pain in the ass to debug. If something goes wrong, there are so many things that can go wrong. Copy paste. Yeah, I wonder what's the probability that we will get the right answer right away. Nothing is printed because we got here, right? Yep. Then I wonder what states at all we considered. For that, I'm going to actually copy my own template. I'm not going to explain what it does exactly, but it's able to print stuff. It prints vectors and stuff like that. Okay, so the first thing is always 0, and we went for a bunch of things, but never did this move. Take the one from the sample. Here you go. Ignore that. Same thing. So what I want to happen is that I want to be able to hit a button. Actually, starting with A should be easiest. So the question is, if I have this, then will I see anything? No. But this should be very easy because initially everything hovers over A. So the first thing that I will print can be A quite easily. Yeah, we start from here. So I wonder what happens if we are in the starting position and I do the hit. I wonder what is apply of move hit on 0 on a vector that consists of hit, hit, 10. I expect A. Q? What? What? Q? What is this? 0 plus get char. Okay. So I get a character and then I add 0 to it. Okay, I see. Much love from Estonia. Thank you, Dante. Okay, so does it work now? Well, it printed 1 correctly. So what was the sample thing? Somebody in the chat told me what I should try. I don't know if it's this. Hey, that's something. Does number 68 appear here? Control F68. Yes, it does. Okay, nice. So now we have some input. And for each of those, how do I want to do it? It will be easiest for me to do it independently. Repeat 5 times. Also create answer. Read the string. Or return 0. Let's make a function. Solve given a string. Now instead of return 0, I'm going to just return this. Here it's assert false, int solve string. Okay. Then 5 times read the string, solve it, and the integer part of the string we convert. A string to int is this. Not good. Do I have any global variables, I wonder? For 319A, assertion failed. If I start from it, so if I ignore what I'm reading and I just say 319A, then what will happen? Oh, yes. This suggests that something is wrong with what I'm doing between the test cases. Anything global? Oh yeah, of course, this. What I basically did is I said that I now want to run it always for this string 319A, and the first time it ran correctly and it's computed some answer, only second time it failed, which suggests that it's an issue with test cases, not with the actual logic for this particular string. And now I see that those arrays I don't clear. Those are big multi-dimensional arrays. I'm going to use memset for that. C++ memset set to 0. No, C++. Okay, where is solve? Will this work? I hope it works. Yes, 40 minutes. That's quite a lot of time, 160 lines. I should have been faster. Wait. Reset the timer, change the text. Now we can start. Second member of the search party has also been missing this entire time. Is this the intended solution? Yeah, most likely. That must be DP. It's just the implementation varies. You can do different things. Historian is trapped in the locked area of the ship. Robots are dispatched. Many more robots are involved. 25. Wait, so just like I predicted, now we have just more robots. All right. Now, is this solvable? I guess for you to print anything, you want the robots to be aligned, all of them on the A button. So even if there are a lot of robots, from time to time, there is this, not exactly invariant, but this situation that will keep repeating, that this robot is here, this robot is here, and this robot is wherever. But this will be consistent. And now, what you want to happen, generally, to move this robot at all the previous robots need to be on particular positions. So if for, like, maybe this. If you want to move 20 of 25 robots, or 26 robots, then first 19 robots should point to A button, so that something would happen. Maybe if you want to move this one, then first 18 robots should point to A. 90th robot should point to proper movement character button or key. And that will do the job. That will move the 20th robot. Now, for that to happen, we want to move this 19th robot. And for those also, it's a very regular thing what will happen. So we are focusing on the fact that the last robot should be moved to some character. For that, you know what should happen with the first some number of robots. Like first prefix of them should be all at A, and then the next robot should be something. Solution to part 2 may or may not be easier to implement than brute force in part 1. I can agree with that. Now, 3 robots was on the boundary of what might make sense to do more automatically. So clearly, for each of the 25 robots or so, I want to compute the cost of moving it from one button to the other. So move cost for each of 25 or maybe even 26 robots. Let's see, how many robots are there? 26. There are 26 robots. I want for each of them to compute the cost of moving it from one button to another. Actually, for the last robot, it's from 0 to 11 up to 0 to 11. So let's say that this is size of the array, but for most of them, it's just from 0 to 4. For example, move cost of 17 of 2 to 4. That says, assuming that the previous robots are all pointing to character A, then how many moves I need so that the 17th robot would move from this button to this button. Also, this will be long. Now, how do I achieve that? If everything before that points to A, first I need to move the previous one to some movement button. So this is equal to move cost of 16th robot needs to move from A, which is the hit position, to some direction, to something. Plus then there is one for actually hitting this button. Plus I might move it to somewhere else and again make a movement. Maybe we need to add here one more dimension for where the previous robot is. That will make transitions easier. So I want to move the 17th robot from this position to that one, and the previous robot awaits here. No, that doesn't help. So for example, then from here you move to something too, some new position, and then maybe you hit a direction button again using that, and then finally you do this and no, from something to something too, and then from something to hit again, because you want to align that previous robot again there once you're happy with the movement. It's it's transitions like that, which is kind of internal small BFS, I'm guessing. Hey, how are you? I'm okay. I'm actually a little bit tired from life and responsibilities. I'm so tired to go for some New Year's Eve party tomorrow. I think I will only go for like 3 hours or so. I don't know if it's better strategy to go at 8 p.m. and go back by 11 p.m. to my apartment, or go there at 10 p.m., be there at midnight, and then go just after midnight. I don't know what's the difference of how socially acceptable those behaviors are. Guess the intermediate ones don't matter, so just do full steps. Well, but I need to do a series of steps to move from one position to another, and between them I'm not going to move the 16th robot back to position A. But leaving before the new year has the advantage of being able to rest in your bed early, even though it's very loud. No, I don't want to roam around whole night. I want to sleep. But at around midnight it's too loud for that anyway. No, ICPC stuff is not irritating me. My responsibilities now include actually arranging stuff related to the new apartments we're getting. So a year ago, we got a loan for an apartment, and now we're actually we are getting it done. Let's say the apartment. I mean, so the development company gave us an empty apartment, and now we need to do something inside. I don't know proper words in English to describe that. Renovation. Is renovation a good word? Interior design? Or something like that. Anyway, for example, today I was in the new apartment to talk about some guy about the AC installation. AC for the climate control, not for accepted. Okay, then, so let's say I'm able to do something like this. Then what I want to do for the answer, that will be move cost of the 25th. It needs to move from the A, which is hit, I think, to whatever the first character in the string is. Then +1 because I need to hit that button. Plus then I need to move it from the first character to second and so on. The last +1 will not be there. Okay, what's some kind of initialization? Because we will go increasingly. What about move cost of 0? Wait, 25 is the 25th robot counting from 0. Move cost of 0. Maybe I should say that robots are numbered from 1 to 26. Then move cost of 0 to anything that's equal to 0 because that's myself and I can move for free to another position. Then move cost of 1 and stuff, that's first robot. Okay, something like that. Refurbish. Okay, thank you. Big boy territory. Yeah. I'm almost 30, right? So I'm kind of an adult now. Now, how much of the code do I copy? Also, this is problem number 21. We are almost 3 hours in. I will finish by the 3 hours mark. So, I don't think I have the strength to do the remaining 4 problems. So one more stream, I guess. Maybe tomorrow afternoon. It would need to be earlier than today. We'll see. Okay. Do we still do that thing with strange hash? Find the fewest number of button presses. What is the sum of complexities? So still the logic is the same, I think. Okay. Well, I will want to use this as a variable, and first, instead of 25, I'm going to use, well, 2, right? Because in the previous problem it was 2. And I want to get the same answer. Once that works, I can go for 25. I don't look 30. I keep forgetting you're 2-3 years older than me. Do I look older or younger than 30? Also, how big the values will be. I don't know if int will be enough. Well, then define int long will do the job. And yeah. Okay, so let's say that there is a variable number of robots using keypads, those with directions. I look 22. I don't know if that's good for a man. You look 36. Here we go. There should be a survey. We would see if the average or median is around 30. Okay, so this. I will be number 0, then those robots 1 to 25, so 1 to m. Then m plus 1 is the last robot, the special one using numpad. How did I define it in the drawing? Move cost. Let's call that DP. So it's DP of robot ID, then from and to. Assuming that previous robots, all the previous robots are set to A, to the hit button, then that's minimum number of moves to move this robot from to. And the previous robots then are set to A again. Okay. By default, DP of 0 and anything is equal to 0. We don't touch that because I can move for free. I don't pay for moving my finger over something. And then for the robot ID starting from 1, ending at m plus 1, I will do some logic. Iterate from and to. So I guess we need to do some kind of BFS, or actually Floyd-Warshall, because we don't know what series of moves the previous robot should do. The previous robot starts at A button, the hit, and it needs to end up at hit, but in between it can do different things. I can either implement here BFS slash Floyd-Warshall, or I can do like 5 for loops, because just few moves are enough to move me from any cell to any other cell. Well, for the last one, maybe we need like around 10 moves. Okay, BFS or Floyd-Warshall. Maybe I do need that previous dimension for where the previous item is. Or maybe this is like smaller DP. Actually, it's not BFS, it's Dijkstra. It's smaller DP of where the previous is and then where I am. And by the cost of 1, I can apply this to myself, or with some different costs, I can move myself, and those costs are here. Okay, let's implement this with Dijkstra. Maybe Floyd Warshall is possible, but I know that Dijkstra is okay, so I'm not going to think more. For every from, and how many cells are possible for this robot? Depending on whether it's numpad or keypad. It's either 5. For the last one, it's 11. For the previous ones, it's 5. So if right now I am here, then I wonder what is my cost, what is the cost of moving me to other positions. I'm going to create some small DP of where the previous one is and where I am. I will start by saying that the previous one is at hit, which is this, and I am here. So this starts as 0. There is also the priority queue /set. I insert a pair of 0 and then hit and from. So this is the set. I take the first element, which is the distance. And then previous. And me. And what I can do, I can either hit this thing, assuming that it's not on the hit, but on the movement. So if previous is not hit, it's on the movement, then this next one I can move. And sometimes it doesn't work. Also, I can try to move it to somewhere else. So that should be easier. For every previous 2 from 0 to 5, I can move it, and I will use the cost of DP of ID -1. So that thing, I want it to move from this to that. And that's my cost plus that one. Let's make a function for that that says that for the new state, which is previous 2 and me, it applies this cost of maybe. Previous me maybe. And it does the following. If maybe is smaller than the current distance, then overwrite and erase the old element if it exists. Okay, movements are considered. Now, if this is not a hit, we have an array that says like apply movement. I think it's this. Make move. And it returns a character. Make move of previous of x. What is x? That's me. I can modify it. Pad. If this is m+1, then it's a numpad, else it's keypad. What make move can return? Movement, error, and that's it. So if this is movement, then I say consider of this previous. Me is changed already because I applied a movement, and that's maybe +1. I spent 1 operation. This way, from here, I also need to create this. Previous is for sure up to 5. This next thing is up to 11. And it's filled with infinity. For now, infinity will be billion, but I might need to change it. Distance shadows. My distance. DP. That's not DP. I need to create it. This problem is diabolical. It would take me 10 to the 9th power hours to implement this correctly. Are you sure? I think that you can, like almost every problem, you can separate it into a lot of things that can be separate functions that you can test and make sure that they are okay. Like making movements and making sure that if you are at this button and you hit the arrow down, then what happens? Having a lot of time to debug helps a lot in making sure that every part of the code is good. So I wouldn't say diabolical, but implementation is not easy. Is that even dependent from the input string? Not really. I could compute it once. So this is more like pre-processing. And solving a string is very easy because you say that by default the previous is A because this is where you are, and then for every character here you increase the total by the dp of 26th character, well, m plus first, from previous, not exactly previous. This should be a value from 0 to 10. I have this function, maybe I should also get this function. If you are a digit, then return yourself minus 0. If you are a, return 10, else assert false. Get int of previous, get int of c. So all this implementation we can erase. Okay, that's how we solve. We first, obviously, we need to pre-process. And answer, do this. Okay. Now dp. dp of 0 is just 0 from 2. By default, this is all zeros. Then for every ID we move, what do you want? Maybe not declared. That should be my distance. Well, it compiles, that's something. Do you think this year had good problems overall? As somebody who is good at competitive programming, I'm not a huge fan of the style of problems of Advent of Code. I don't know how to compare this year to the previous years because it's the first time that I'm solving all the problems. I think next years I will just stick to solving a couple of problems that I find interesting or that somebody recommended to me. Going through all of them, that's not fun. It's hard for me to imagine who should solve all of them. Well, if it's fun for you, obviously do it. But if you're not strong, then it will be impossible for you to solve all of them. If you're strong, then it will be tedious / boring to solve all of them. Maybe there is that that nice place where you can be in terms of your skills, where it's interesting to you, but still doable and not boring. Favorite CP problem? I would need to stop and think too much about it. I don't know. I like this problem. Given an array of numbers, count ways to split it into subarrays so that every subarray of length k would be a permutation of numbers 1 through k. Modulo 1,000,000,007. And it is possible to be done in O of n. So there are 2 at power n minus 1 ways to split an array into subarrays. Among them, count those where every subarray that you get is just a permutation of numbers from 1 to the length of the subarray. I like this problem. Oh, recent favorite CP problem. Okay, I misread your question. Then I don't know. I will not think now. I like one constructive problem from one of the ICPC trainings, but I would need to find it. It was about number theory, creating a tree, something with modulo operations. Okay, what was I doing? I need to now this thing small. I need to in some way move to the DP. If id is equal n plus 1, then it's 11, otherwise 5. dp of id from 2. I need the previous one to get back to hit, and I want myself to get here. Done. Okay, we have overflows. Also, I want to try this, and we should get the same answer as we had before. Oh, the answer didn't change after me changing m from 25 to 2. Am I not using it? I mean, maybe there is a way to prove that number of robots doesn't matter, but I highly doubt it. Okay. First of all, or maybe the answer is in some way divisible by 2 at power 64 or 32. Let's do this ugly thing. Where is the infinity? Yeah, it's obviously wrong that this value does not affect the answer. Okay, we have some errors. Line 149. This one. What is hit? Hit is 4. Also, this shouldn't be infinity, I'm guessing. So that's wrong too. From so this is small where this is previous. dp of, okay, this should be 11. Now, still their issue is that some values are just infinity. And then we have overflows, but this is already a bigger issue. From 0 to 1, it wasn't populated by anything. Why? We have a lot of zeros, that's good. But then this thing is infinity. So do I not... Oh, well. First we want to do this so we would print correctly. Okay, so from 0 to 0, from 0 to 0 it's 0, but from 0 to 1 it's bad. As if this small dp didn't move forward at all. When do we return the movement? And now apply is something we don't use, right? Yes. Okay, this is a valid movement. Priority queue, you might want to insert negative distance. I don't see why. Might want to set insert negative. Why is that? I start by saying that, but I don't use priority queue. I see that the name is confusing, but this is actually a set. Consider function missing assignment. Where in the make move? Oh no, in the consider. Oh, line 115. Yeah, that's a funny mistake. Some kind of flags should catch it, I think. That's a strange comment. This is equal to maybe. That wasn't a correct Dijkstra. Thank you, Dark Thunder. Sadly, still the same answer, which is suspicious. Ignore that. Still some kind of mistakes inside of the Dijkstra, I'm guessing. This is 0. I am 0. Okay, maybe after from equal to 0. Let's here say exit 0. I don't want to see so much stuff in the output, first of all. Let's clean this a little bit. So I now just have this. From equal to 0 is one of the directions. And I don't see a possibility of moving to another button. Let's print the consider that is at all done. I consider moving that the human hand to other buttons, but then they should be able to hit something. If previous is not hit, why do I don't insert to the priority queue or the set? Dijkstra so hard. Okay, we get some values. Let's remove this. Now, what was the answer? Not quite correct. But it's good magnitude, right? Also, I wonder how fast the answer grows. Roughly times 3. So it will be of magnitude 3 to the power 25, which fits in long log. Okay. Now, how will we debug this? AI will be able to implement Dijkstra for us without these bugs, correct? I don't see a way better than reading the code line by line. I can also use the previous code for some extra debugging, like I can tell it to tell me the shortest path from one state to another. That might be smart, actually. Because I can here print dp of, I'm not sure what that means, but dp of 1 from one state to another. What does it mean? It's the cost of moving this thing from one button to another. So the cost will be 1 or 2. It's a 2. If I want to move it somewhere else, it's a 1. Okay, so that's easy. I can also print that for the other robot. Then it's 5. And here it would be a little bit more. And now I can verify if the other program confirms that. This is cost, assuming that the first robot is pointing at A, then this is the cost of moving the second robot from position 0 to position 1. Can I use this code to tell me what should be the length? That's a lot of values. The first robot, let it be on the hit. The second robot, I want it to be at 0. The third robot, I want it to be... Also, let me copy this code instead of changing it here. I don't know how to call it. 21 copy. Here I will Control Z those changes. Okay, third robot doesn't matter where it is. Let's say it's at hit. But whatever. Now I want to say distance for robot 1, robot 2, robot 3 is 0. And then we do this. And I want to here say, I'm not really interested in you. But if robot 1 is at hit and robot 2 is at 1, then return. And I just want to print X and return 0. 8. Okay, and like that we can debug some stuff. Now what if I want to move the third robot like this? The 21 part 2. Nope. 21 part 2. This tells me 24 moves. And this thing, what will it tell me? The copy. If I want... So you point at hit. You start at 0, and for the final state we have this 24. That's correct. What if I want to move it somewhere else? Here to 11 only, and here $11. Okay. So some basic values are computed correctly. Maybe even the whole DP thing is computed correctly. Let's try something else. From 4 to 1. From 4 to 1. That's incorrect. Okay, good. No, not like that. I was supposed to change this from 4 to 1. Okay, it's correct. Do we still have the FAQ command? Yes, we do. You can check out this link for common questions like what editor I use. Some answers to those questions might be not up to date because I wrote them. Well, last time I updated it 4 years ago. I wonder how much I would change. Does it work on YouTube? Oh, I see the link is not pasted. So that's strange. Strange that the stream elements message is not copied. Maybe because it's an exception. Don't know. Okay. So now it seems that the DP array is computed correctly. Well, but if the DP array is computed correctly, then what is wrong? Do I correctly move from somewhere to a position like 10? So what if I want to go from 7 to 10? This should be quite far away, I think. 23. From 7 to 10. 23. Then am I doing this part incorrectly? We start at A. We want to go from previous element to next element in the string. For Dijkstra, are you returning one path? I'm not finding a path. I'm just finding the distance. So yeah, it's distance of a single path. Wait, I know what I can do. I can print x values in both solutions as a test. 21 part 2. So this I don't want to print. Here, same thing. Oh, so just in 21, print x. The values are different, but they are greater by exactly 4. I'm not doing something very trivial. All that time was wasted. Should I just add +1 somewhere? Oh yeah, obviously. This is the cost of moving from one character to the other. +1. Done. The answer is the same. Okay, then I just need to say 25 instead of 2. Run. Fingers crossed. That's the right answer. 50 minutes. That's a lot of time. Shouldn't you add one for every character in S? Yes, Maxim, now I agree. I figured it out before I read your message, but after seeing that values differ by exactly 4, those versus, where was it? Here, 66, 66, 70 versus 70, 70, 74, it was easy to figure out. People took a lot of time for this P2. This was problem 21. Okay, so best score 23 minutes, reasonable scores around 30. How much did it take me? Anybody remembers? I can actually, or yeah, please somebody check. How long did it take me to solve P1? You can rewind the YouTube stream, I guess. Oh, wait, this is 2 stars. That's embarrassing. I wrote +1 in the formula when I was thinking. Oh yeah, I did it. +1, +1. So I knew that I should do it. Right, but my 50 minutes was for P2, right? And P1 was another 40 minutes, so I did hour and 30 minutes. I wouldn't be in top 100. But it was random that I couldn't do the +1. Yeah. gone 40 minutes. Thank you, Gupta. Yeah. Maybe next year I will try a couple of problems while without talking and actually try harding. We'll see. Okay, 21 problems solved, and 4 remain for another stream. Maybe tomorrow. I would prefer to finish it this year instead of leaving it for January. So it's very likely that I will go live tomorrow, a bit earlier than today. Maybe it will be around 3 p.m. Polish time, and we'll do the last 4 problems. And unless they literally take me 1 or 2 hours each, I will want to finish the Advent of Code 2024. Fast stream tomorrow. Yeah, fast stream. Every problem 10 minutes, easy. I will plug everything into ChatGPT. Template for Dijkstra. Oh yeah, I also wasted a lot of time because of Dijkstra mistakes. So the second part, 20 minutes was possible for second part easily. One could also maybe figure out in the easy version how you can do it for arbitrary number of robots. I think I said out loud that maybe hard version will be about multiple robots, like 20 or 100. So I had some chance of skipping easy part if I knew that. Rest should be easy except maybe 24 part 2. We'll see tomorrow. What's the time here? It's 8 p.m. Okay. So thank you everybody for watching today. Hope you enjoyed me struggling a little bit and finding mistakes. Thank you for talking with me. And most likely, as I said, see you tomorrow around, I think, 3 p.m. Polish time. But I will decide about it tomorrow. Actually, do I have something in calendar? No. Yeah. So have a good evening. See you. Bye.